This video is going to demonstrate how to perform several data cleaning tasks in Excel. This corresponds with Chapter 2 of our textbook, Applying Data Analysis in Psychology, Exploring Diversity with Statistics. For this exercise, we're going to use a real-world data set. This random subset of the larger data set comes from research on stigma associated with intellectual disabilities collected from several different European countries. The researchers who carried out this study found that there were some differences between individuals from different countries and how easily they identified that a hypothetical person described in a vignette scenario had characteristics that would indicate an intellectual disability. They also found that the attitudes of people in different countries did differ in how they viewed that person with a hypothetical intellectual disability. We're going to focus on a data file that has a few key variables from their data set, including some demographic information, social distance ratings on how closely they would want to be associated with this hypothetical person, and responses to that individual with an intellectual disability. There was a lot of other data gathered in this study if you want to check out the original research article that is cited here. The specific functions we're going to walk through include how to handle missing data using Excel functions, how to count up how much missing data a person has, spotting some specific cases using conditional highlighting, recoding variables when we have reverse worded items, creating scale scores to average or sum different variables assessing the same construct, use Excel's tools for sorting data to be able to view different high or low values, and also how to save Excel so it can be in a different file format, specifically a CSV format, in order to import it into JASP. Here's what our Excel file looks like. This data from our example research study can be found in the Chapter 2 materials with our textbook. First, we want to get a feel for what is the layout of Excel. You'll notice that every column has a letter associated with it, with columns A, B, and C, and every row has a number associated with it, with rows numbered 1, 2, 3. You can talk about an individual cell with the combination of its row and its column. For instance, if I click on this cell, it's designated up here as cell A1 because it's in column A and row 1. Typically in data sets, we'll see that this first row is going to provide the variable information or the variable names for what we're working with, all of those items that were collected in the survey for this study. And then each row after that represents an individual participant. And so you'll see a random participant value here, and there's the responses to each of the items that they responded to on the survey. The columns are going to indicate your different variables. So for instance, in column B is the response for country of residence for all of our individuals. The first task we're going to look at in order to use some of our Excel skills to get our data file cleaned up is to learn how to rename some of our missing data. In this data set, these values of 999 were used to designate missing values. This is a common practice researchers do sometimes because 999 is usually a nonsensical value for most things that we're collecting, and so it can be easily identified as missing rather than just having a blank cell and is clearly not a meaningful value. Let's say though that as we import into JASP, we don't want those 999s in there because those could mess up our analyses. Instead, we do want them to be blank cells. And so there's an easy function we can use in Excel in order to change all of those 999s from this value to a missing value instead. So what I'm going to do is I'm going to select all of the data in this data set. And we have, in this particular data file, we have around, you can see 147 participants because we have one row with labels, and we have a number of variables collected. And so an easy way to select all of this data all at once is to click this arrow in the upper corner here, this triangle, and as we click that button, it's going to highlight every piece of data. And so from there, I can go to the little magnifying glass here that is the Find and Select option. And if I click that drop down, I can click Replace, which is going to allow me to find instances of certain data and replace them with something else. So if I click that menu, I'll see my Find and Replace menu pop up, and I want to indicate what I want to find and what I want it to replace with. In this case, I want it to find instances where data is recorded as 999, and I actually want to replace it with nothing. I'm going to leave my replace blank. If I wanted to change it to another value, I could type it in there, which can be really handy if you just want to recode some data. But for now, I'm just leaving it blank because I want 999 to become a blank cell with nothing. Now I'm ready to go ahead and click Replace All, and it's going to tell me how much data was replaced once I hit that. So it says all done. We made 320 replacements. So we can click OK. Then we can go ahead and close out of this menu because we're done using the Find and Replace function, and you'll see that all those 999s that were previously there have been replaced by blank cells. Next, we may also want to know how much missing data do people have. We took away those 999s, but we might want to know how often were people not responding to a particular item. We're going to use a count missing command to be able to find how many values are missing. To do this, we're going to create a new variable. So I'm going to go all the way to the end of my variables for column V, and I'm going to type a quick label in this top row. I'm going to call it count miss for count missing. You'll notice that I put an underscore or a hard space here because JASP won't like when you have spaces for your variable name, so I'm going to designate a hard space there by using the underscore function there for count miss. Now in the first row of data is where I'm going to start my formula that's going to tell Excel how to count that missing data. And so anytime we start a formula in Excel, we start with an equal sign because this cell is going to equal some computation. The function I'm going to use is called count blank, and you'll see that my pop-up menu here displays count blank's function, which counts the number of empty cells in a specified range of cells. And so I need to type the command, and then in parentheses, I'm going to tell it what range to look in. Where should you look in order to count those blanks? And I'm going to click and highlight all of this data for participant 1. So I'm going to be going from A2 all the way through U2. So you can either click and highlight those or type in the specific addresses of A2 through U2 and put an ending parentheses and push enter. This should return a missing count of 1. So this person had 1 missing response, which if we go back through their data, we can see that the variable that they were missing was this ID recognition. So did they recognize someone with an intellectual disability? They did not complete that variable. The neat thing about Excel is that we can now copy and paste these functions, and it will follow the same pattern for the rest of our individuals in this data set. So to do this, I can either click on this cell and then right-click copy, or Control-Command-C, and then I can highlight below for all of these other participants that are in our data set all the way to that row 148. And I can paste there either using Control V or the right-click paste function. And so this completed my process for all of my different individuals. I counted 1 missing piece of data for this participant in row 3, 1 missing data for this participant in row 4, and 7 pieces of missing data for participant in row 5. Another easy way to do this is to click on the cell that has your formula in it and locate this little square, the little green square in the bottom corner. And this is a copy and paste function. If we click that little green square and hold down our mouse and drag it all the way to the end of the selection, this will do the same thing as a copy and paste function. It just takes that function and drags it and applies it to the rest of the data set. So that will do the count missing for every other case in our data set. And you'll notice when you click from cell to cell, we first type the formula count blank for A2 through U2, and as we move to our next cell, it's just going to be doing that for that next row of data. So it shifts the formula down to say count blank for A3 through U3. And then we get to the fourth row and it's going to be A4 through U4. So it will naturally move down with your data as you go. So this provides us with our count missing. Now we can easily know the number of missing responses we have, and say if we wanted to limit the number of missing responses, we could filter our variables based on that. Let's say in this example, we want people to have answered at least 70% of the variables, and so they need to have answered 14 questions and have no more than 6 blank responses in order to meet that qualification. So let's use the sort and filter function to look for any cases that are missing more than 6 responses. To do this, we again want to make sure our data is sorted all together, so I'm going to click that little triangle in the corner again to select all of my data. Then I'm going to go up here, this little symbol here that has A to Z and a little funnel there is the sort and filter function, and I'm going to select custom sort. Custom sort allows you to specify exactly how you want to sort it. The first thing I'm going to make sure I have checked is that my data has headers, and that just signifies that that first row of information is my variable names. It's not something meaningful, it's not a participant response. I'm going to request to sort my data by that new count missing variable that I just created. And I'm going to sort it this time. I can do smallest to largest or largest to smallest, but because I want to see those with lots of missing data, I'm going to do largest to smallest. So in sum, I've said sort by count missing as the variable, sort based on those cell values, we won't change that, and then we're going to order it largest to smallest. And when I click OK, I'll see that all of my data is rearranged so that those with the most missing data are up at the top now, with some that are missing 9, 8, or 7 responses. Another useful trick in Excel is that we can create some functions that'll help us spot really easily something that we're looking for. And so I could just look here and see which ones have more than have 6 or more missing responses. Another function I can use is to highlight cells. So I'm going to highlight just column V this time, just the data in that count missing column. And I'm going to go to this function called conditional formatting. This means you select a condition and it formats it based on whether or not it meets that condition. So I'm going to use the highlight cell rules option, and I'm going to say I want to highlight any numbers that are greater than a specific criteria. I said I didn't want people to skip more than 6 questions, so I'm going to highlight anyone with a count missing greater than 5. So then we can simply say highlight format cells that are greater than 5, and here's where we can clarify how to format it. The default is to convert it to red text with red shading, but there's a whole lot of other options you can select here for different highlight options of highlighting it green or yellow or customizing it in some way. I'm just going to leave it on its default and click OK. And so now I see those people who were missing more than 6 responses are highlighted in red, and so that will make them easy to detect if I want to filter them out at some point or if I just want to remove them. If I wanted to remove these cases from my data set, I could remove the entire rows by highlighting rows 2 all the way through 29 or 30 now, and all of those are the ones that have been flagged as having excess data. If we want to delete rows, we highlight them all at once, and then you can right click and select delete. And this will delete all of those rows from your data. And so now our data is in a cleaner format that only has those that are missing 5 or fewer responses rather than missing over 70% of the responses for these questions that were asked. Now, in practice, lots of times we don't actually delete those cases. We might filter them out, but right now we're just going to learn about how to delete these rows, and you'll learn filter functions in JASP as well as a good alternative to deleting those selections instead. And we want to use, again, the conditional formatting, and I'm going to use the highlight cells rule, and I'm going to say this time I want to highlight cells that are greater than 17. So they need to be older than 17 in order to participate. And let's say we just want to change this to green fill instead to highlight that they've met this criteria. It's essentially a check mark for us. And so we're going to highlight everyone who has an age that's greater than 17. And we'll see if we had all of these cases included. And so we'll see that as we scroll through our data, we had a couple people missing age, but most people are 18 or older. As we scroll through, we just have here one 17-year-old and a second 17-year-old that don't actually meet our criteria. We're going to filter those out in JASP later to show some filtering options, but we could remove them or exclude them from our data because we don't want these cases to be included that didn't meet our study criteria. The next skill we're going to learn is how to recode a variable. So sometimes we have scenarios where some items are written in a positive manner and some are flipped and they're written in maybe a negative manner. So for instance, let's take some of these social distance items that we have. We wrote these so that higher values represented a greater openness, but if we wanted to conceptualize this more as social distance, we would want to reverse how these are coded. And so whenever someone provides, for instance, a 4, we would want it to be the opposite of that, where when we reverse this, essentially a 1 would become a 7 instead, and a 7 would become a 1, and everything in between would be converted. And so this would mean that we've flipped our scale. And so a shortcut to doing that is to take whatever our highest response option was, in this case it was a 7, and to do that plus 1 and then subtract the response. And so there's some more detail on that in the ebook, so you can see this written out in a little bit more detail. But we'll start working through that example with this first social distance item. So social distance 1, I'm going to insert a column next to it. If I highlight column J and then right click, there's an option for insert, and this is where I insert that new variable. And so I'm going to label this SD1R because it's the social distance item reversed, and because there's 7 points to this, I'm going to get that response by simply doing 8 minus the response they actually gave. And so when we do 8 minus 4, that will convert it to a 4, which remains the same. But when we do that for an item like someone giving a 7, then 8 minus 7 converts their score to a 1, the lowest possible score instead of the highest possible score. As before, we can use that little green box. If you click on it and look for the little cross to appear, you can click and drag that function down to repeat that function for the rest of the participants, or you can copy and paste it. But you'll see that for every participant, their score has been flipped. If they gave a 1, their reverse score is a 7. If they gave a 7, their reverse score is a 1. If they gave a 6, it's a 2, and so on. So we see that these scores have been reversed and flipped so that now a higher value means more distance between the person. You can give this a try yourself too by completing this for the other items. I'll do one more with you and then you can complete the others on your own. So we'll insert another cell next to our second social distance item, and I'm going to label this SD2R. And I'm going to use that same formula, 8, which is the highest value, plus 1, minus the actual value they gave. And so that 4 is converted to a 4 again, and I'm going to copy and paste this all the way down to the end. And now we see all of our items have been flipped. Go ahead and give this some practice by also reverse scoring the remainder of the social distance items. So we have items 3, 4, 5, 6, and 7 that you can go ahead and reverse score. After completing that exercise, you should have now 7 original social distance items and then 7 reverse items. Mine are labeled so that each pair is right next to each other with item 1 in the reverse, item 2 in the reverse, item 3 in the reverse, and so on for items 4, 5, 6, and 7. Now that was reverse coding where we want to change one value into its opposite. Sometimes we also might want to combine some groups or change the response values for a particular item. So we're going to use another if-then function to learn how to recode another variable in this data set. This time we're going to recode residence. And so residence was coded as 1 if someone in the survey came from Austria, 2 if someone was from Germany, and 3 for someone who is from the United Kingdom. In the study that they did looking at how different countries could identify or their attitudes towards someone with intellectual disabilities, they found that Austria and Germany really weren't very different, and so they combined these individuals into one group. We can do the same thing in our data set. So we're going to insert a column to the left of our residence variable. So I'll click on column C and do right-click insert in order to insert a column there. And I'm going to call this new column residence to category because we're simplifying it to 2 categories. We're going to use an if-then statement to recode this into either UK as one group or Austria and Germany for another group. So one way to do this is to use an if-then function where I again start with an equal sign, meaning I'm doing a formula, and I'm going to say if, and I need to figure out what is my condition. So it's going to do a test to see if a condition is true, and then I'm going to tell it what value to give if that condition is true and what value to give if it's false. And so we're going to see if this value for residence is equal to 3, which was signifying someone being in the United Kingdom. And so if they're in the United Kingdom, we're going to give them a value of 1. And if they're not a 3, that means they were in Austria or Germany, then we're going to give it a value of 2. And so that is a pretty simple looking formula, but what it's saying is if this person's residence value is 3 or UK, we're going to label it as 1. And if it's not the UK, we're going to label it as 2. And so we know that there were only 3 groups, so everyone labeled as 2 is going to be either from Austria or Germany. And so if we push enter, we'll see that this person has a 2, and so their response was given a 2. They weren't from the UK. If we copy that formula down, it's going to repeat that same logical test for every row of data and assign a value. And we'll see as we scroll through that people from the UK that originally had a 3 are converted to a 1, and anyone who was a 1 or a 2 from Austria or Germany is now labeled a 2. So this is our simple revised categorization where 1 is UK and 2 is Austria or Germany, since those 2 did not vary from one another very much. Now that you've had some experience with recoding, we're going to move to a common next step that we use in research, which is to create scale scores. Sometimes we ask a series of questions that are measuring essentially the same thing, and so it makes more sense to be able to summarize them into one score rather than analyzing a bunch of separate questions. So we're going to first create a social distance score. We just created all those reverse worded items or reverse coded items so that we could combine them and that we could create a scale score where higher values indicate more distance from that person. To create our scale score, I'm going to insert a column at the end of my social distance variables. So for me, oops, I just deleted instead of insert. I'm going to insert a column here. I'm going to call this SD average to indicate an average score on the social distance measure. And so to create that, we're going to start a formula that is used to calculate an average. So I'm going to do equals average, and then I need to indicate what numbers I want it to average. Sometimes this is easy if numbers are right next to one another. Sometimes we have to select a bunch of different cells if they're not next to one another. In this case, they're not next to one another. I want to use all of the reverse items, so I'm going to click or type the cells that indicate the values for each reverse worded item. So first, the social distance 1 reverse, and then I'll include a comma to separate that this is a separate cell. And then I'll click or type M2 for the second reverse coded item, and then O2 for the third reverse coded item with a comma afterwards, and then Q2 for the fourth item, S2 for the 5th item, U2 for the 6th item, and W2 for the 7th item. And so my command says take the average of these 7 cells, which are the responses to the 7 social distance items, reverse scored. And so when I click enter, it will calculate an average score of 5 for this particular example. And then I'll ask it to do the same thing for all of our items as I scroll and put that formula and apply it to all the rest of the selections. So you'll see it calculates an average for each row of data. And you'll see again that it's used that approach where it shifts down. Now it's using all of the cells for row 3 to calculate the second person's average, and all the cells from row 4 to calculate this next person's average. So following the same columns, but shifting down in rows. And so now we have our set of average scores for the social distance scale. Now we're going to create a second type of scale score where we're going to create a sum instead. So this time we're going to look at our response variables. How would you respond to someone with an intellectual disability? And you'll notice that we have different responses. The response could be that someone feels uncomfortable. A response could be someone feels irritated. They could feel annoyed, or they could feel like they want to help someone. They could also feel sorry for them. They could also generally feel some remorse for them. And so we want to first summarize the more negative responses. Those first 3 that I mentioned here were uncomfortable, irritated, and annoyed. Those are more negative responses, while the next 3, you want to help them, you feel sorry for them, you generally feel for them. Those are more compassionate responses. So we're going to try to sum up these 3 negative responses. So I'm going to insert a column next to those 3 negative ones, and I'm going to call this column name negative response. Something like that to give it a name for this is going to be negative. And my formula for that is going to be equals the sum of these 3 cells, the 3 negative response cells. So I'm going to sum up for this first person rows or cells Y2 through AA2. And so it'll sum up to how many negative responses or negative emotions did they feel. And you'll see for this person, they had 3 total negative responses. So we summed up those 3 items here. And we can again copy and paste that formula or click and drag to apply that formula to the remainder of the cells. And so now we have a sum of all of our different negative responses here. And we could do the same thing to create a sum for the more positive responses or compassionate responses. So we could insert next to our count missing variable here, insert a compassionate response. So we'll call this compassionate response. And then we're just going to do the same thing, but we're going to sum up the 3 more positive or compassionate responses that they had for those items of help, sorry, and feel. And so if we add those up, the score for the first person is 10, even though they had a missing response here. And we're going to apply that formula again to the rest of our individuals. And so we have our full scale scores that we've created, a sum score for negative responses and a sum score for compassionate responses. So that will summarize all of those new variables that you've created. You've created the recoded and reverse coded variables, you've created an average score, and you've created some sum scores. The last thing I want to highlight is how to save your file in different formats. And so going back for this file, it's currently saved as an Excel workbook from the option that you downloaded. That extension of the file is usually .xls or something like that, but we can save it as another file format. So if we go to File and Save As, you can find a location somewhere on your computer that makes sense. And you can save it either as this Excel workbook, which is really good for preserving all of those formulas and the conditional formatting that you do. So I always recommend keeping a copy that is an Excel workbook. You can save it like that now. And you can also save it as a CSV file. This is a very simplified file that just contains the numbers, and that's what we can use to import into JASP. So first, again, save your file as a regular Excel file. And so, for instance, we'll call it our walkthrough example complete, and I'll save it so that I have that option done. And then I'm going to also save as and make this a CSV version. And maybe I'll change the name to say something like complete CSV, and that can be imported to JASP, and you save it there. And you want to make sure you've selected a file location that you're going to be able to find easily. You can signify a specific file location in that Save As menu by locating, usually clicking more options, or browse. Browse will bring up all of your different folders that you're in, and so you can make sure you save it somewhere convenient, like your Documents folder or your desktop, wherever you can easily find it again. So that concludes the first part of working through this with Excel. In the next video, you'll be able to learn more about how to incorporate this into JASP, how to import this data into JASP, and how to work with JASP for some primary functions.